All right, guys at home, good morning. Can I get a thumbs up that you see the board and hear me okay? Okay, great. So guys, we are starting section 5.7. Chapter 5 is like the never-ending chapter. It actually has 9 sections in it. So hopefully by the end of next week, we'll be done with chapter 5. This is a wonderful section in the sense that, yes, it still deals with exponentials because the formulas for financial models are variables, the exponents, so that is an exponential function. But it's real simple in the sense that we just use the formula and then our calculator does all the work for us. We just have to know all of the components of all of the formulas. All right? All right, so here we go. The financial models are going to deal with interest, which is probably one of the most real world topics that we actually talk about in this class. Interest is the money paid for the use of money. So there's good interest when you are investing, whether you have money sitting in a bank account, or there is bad interest. Bad interest is probably what you'll deal with the most in your life. When you borrow money on credit cards, you're gonna have to probably have a credit card at some point, and you're gonna borrow money at some point, whether you go to buy your first car or you go to buy your first house, you are going to loan money from a bank, okay? And that's the bad interest. For the most part right now, we're gonna be dealing with the good interest on the investing side, okay? So there's 2 types of interest that we're going to calculate today. Number one is simple interest. And this is probably, I can't even think about really where simple interest is used anymore, but it's simple interest that creates the compound interest. So we at least start here. So simple interest is interest that is found on the principal, which is the original amount. So you throw $100 into a savings account, $100 is your principal, okay? It can be found one time at the end of the term. So the thing about simple interest is they're going to give you an interest rate on your money for a specific amount of time. But that interest is not going to be added into your total amount of money until the end of the term. Where compound interest is going to take your interest a little at a time and add it into your money. So on the next period, you're earning interest on top of the interest that they've added in, okay? But let's do simple interest first. So before I give you the formula, what is the interest earned if you invest $500 for 5 years at a simple interest rate of 10% per annum? And most of your interest rates, they are per annum. That's the amount of interest per year that you can earn, all right? So guys, think about this. They're gonna take your $500 and they're willing to give you 10% of it each year for 5 years. But with simple interest, they are not gonna take that interest and add it in until after the 5 years. So guys, what is 10% of your $500? So $500 times 10%, guys, that's 50 bucks. So that means at the end of year 1, they're gonna give you $50, 10% of your 500. At the end of year 2, they're gonna give you another 50 bucks. They're gonna give you 10% of your $500. At the end of year 3, they're gonna give you 50 bucks, 10% of 500. At the end of year 4, they're gonna give you 50 bucks, 10% of 500. And then at the end of year 5, which is the end of your term, they're gonna give you another $50. The thing is, you don't get to see this $50 in your account until after the 5 years has ended. Where a lot of times with interest, after year 1, they'll add the $50 in, and now you have $550 sitting in your account for year 2. And now the first $50 earns interest all the way through during year 2. So interest earns interest. But that's not how simple interest works. So now that the term is over, that's what? That's 5 times 50. That's 250 bucks. Now they added it. So now you have your $500 plus the 250 you earned in interest. Now after 5 years, you would see a total of $750 in your account. So guys, an easier way to do that is to calculate your interest earned, is to take your principal, the $500, times it with the rate, and then times it by the time, 5 years. So simple interest is literally found just by taking your principal, your rate, and your time and multiplying them together. And again, with simple interest, they do not add any of this money in until at the end of your term when 5 years is up. interest does not get to earn interest with simple interest. All right, so look at example 2. Oh, good call. I never hear that, nor do I pay attention. Is there a hand raised or a chat?
Yes.
What's up?
With the PRT music.
Okay, so I should probably write that. So I will be your interest that you earned. P will be your principal, which is just the original amount of money. It's your initial value. It's the original amount of money. Whatever money you start with. R is your rate, and we use it as a decimal. And then T is your time. And time, for the most problem when it comes to these investing, your time is always wanted in years. How many years do you plan on investing this money for? Oh my God, I keep writing that. Okay? Thanks, Jay, I should have written that. All right, so look at example 2. Example 2 says, what is the interest due if $1,000 is borrowed for 6 months at a simple interest rate of 6% per annum? So again, guys, that's an interest rate per year. It's 6% of your money per year. So in this case, let's just use the formula. The interest earned on this loan is going to be, your principal is $1,000. Your rate is 6%, which is 0.06. And then your time, guys, you're only doing this for 6 months, which is how much of a year? A half, right? 6 out of 12 months. So either 0.5 or 1/2. Multiply all that together, and that will be the interest that you will have at the end of your 6 months. And I believe it's $30. Yeah. So you will have $30 earned in interest for this money borrowed for 6 months. So that's the thing about borrowing money, it's not free. The reason people pay money back that they borrowed is because they're being charged interest. So that $1,000 that you borrowed, that you only got to see, now is $1,030 after just 6 months. Now, that $30, you didn't even get to use it. You owe the bank that money. So that's the interest that will get you. And that's why you have to be careful with credit cards. Never put something on your credit card that you can't pay off at the end of the month. Because credit card interest, guys, this is 6%. Credit cards usually start your first one probably around 23, 24% interest. So now you go put $100 on your credit card. If you don't pay it off at the end of that month, they're going to add $24 onto your account. And you didn't even spend it. You didn't even spend $24. But now instead of owing the credit card company $100, you owe them $124. And then the next month, it sits there, and that $24 that you really didn't even spend is earning interest. So credit cards can be scary. So be really, really careful with credit cards. My rule is, if I can't pay it off at the end of the month, don't put it on your credit card, because it's just going to earn way too much interest. Okay, but here's the thing. Simple interest is rarely how we do things anymore. What happens now is, interest is rarely found on the principal amount only, right? Simple interest only takes a percentage of the original amount you put in there. 10% of 500, 5 times. 6% of 1,000, 1 time in the course of 6 months. Usually the way interest works is they have these compounding periods where they'll, along the life of your term, they'll stop, calculate your interest, and then add it in. So that the next period, your interest gets to earn interest. And that's usually how we deal with money. So interest is most often added into the principal amount over certain time periods. Compounding periods is what they call them. And interest starts to earn interest. This is called compound interest. So if your interest is going to earn interest, that is something that is being compounded. And this is the formula we use for that. And I'll explain what all the variables are.
The P is also capitalized, right?
Yep. Capital A, capital P.
Is that L or is that 1?
A 1 plus R over N to the power of N times T. Okay, so A is going to equal your end amount. How much money do you end up having after this interest is calculated? So that's going to be the end amount of money. P is going to be your principal. So that's the original amount of money. That's your start money. Sometimes they'll call it the present value, what you start with in the present. That's the original amount. Again, and sometimes they'll call it the present value. R is your interest rate, and again, we use it as a decimal. And again, it is a yearly interest rate. It's per annum. N, guys, N is the number of times that they are willing to stop along the life of your loan, calculate interest, and add it in. It's called your compounding period. Are they willing to add your interest in twice a year, 3 times a year, 4 times a year, 12 times a year? How many times do they plan to let you add interest into your principal amount? It's the number of times they are going to stop, calculate some interest, and add it in so that your interest can earn interest. And then T is time. How long do you plan to either borrow or invest this money for? And normally, they always want time in years when you plug it into the formula. So guys, basically what happens is, the way this formula works is your rate is an annual interest rate. So if your rate is 10%, right? And they're gonna compound your interest twice, let's say halfway through the year and at the end of the year. You don't get the full 10% interest rate at each compounding period. You only get 10% overall for the entire year. So if they did it twice a year, 6 months in, they're gonna calculate some interest, but they're gonna take your rate and divide it by 2, because you're gonna get half of that rate at the 6-month period, and you're gonna get the second half of that rate at the second compound period. So you only get the rate divided by how many times you're going to calculate your interest in that year. You don't get the full rate at each compounding period, all right? So what happens is, this is your principal. You're gonna times it by 1, because that's like if I had started with $500, then 500 times 1, I'm gonna have $500 in my account. And then I'm gonna do my principal $500 times the rate, but I do have to divide it by the n, the number of times I compound it. And then guys, you're gonna do this n times throughout the t years. So it's to the power of n times t. So it's literally just taking your simple interest and making it into a little bit more of a usable compounded formula. Okay, so here are your compounding periods. If they say they're gonna compound your interest annually, guys, that's once a year. So n would be 1. If they're gonna compound your money semi-annually, that's twice a year, so n would be 2. These are the normal, most popular compounding periods. If they're gonna do it quarterly, well guys, there's 12 months in a year, so that's 4 times, a quarter of 12. So n equals 4. Monthly is 12 times a year. At the end of each month, they're going to stop, calculate some interest, and add it in. So guys, that's 12 times a year. They would be adding interest into your principal. So that's n is 12. Weekly, there's 52 weeks in a year, so n would be 52. 52 times they would take your money, calculate some interest, and add it in. Daily is 365. And then guys, it becomes the question, after they kind of say every day or each year, what if they said without bound? What if they said we will compound your interest continuously, which means every instant of every second, of every minute, of every hour, of every day, of every week, of every month, of every year. They're willing to constantly be calculating interest, adding it in, so your interest is constantly earning interest. what number could we use for n that would represent a big enough number for every get? It's basically infinity, right? However, infinity isn't a number, it's a concept, right? It's the biggest number that they go on forever. So you couldn't passively plug infinity in for n in the problem, but if you notice this formula, if n was really, really big, like say you had 1 plus, let's say your rate was 100%. I know it probably wouldn't be, let's say it was. And then over n to the power of n for so many years. Guys, does anybody recognize what this formula is? 1 plus 1 over n to the power of n as n goes to infinity. As n is a really, really big number. What did we learn this number became when n went to infinity? It became e. That's e. E is the limit of this number as n gets bigger and bigger and bigger. So if they're going to compound your interest continuously, this number is going to be e. So you get a new formula for this one, and it's going to have e in it. So if they're going to compound your interest continuously, that's the key word, you're going to use a new formula for that. It's going to be e. All right, let's try the other ones and watch how easy this is and how it all just depends on the calculator doing all the work.
Can I take a picture?
What? Yeah, absolutely. Yep, you're fine. Okay, let me write the formula. All right, so we're going to use all of this information to do all of these examples. All we're going to change is the compounding period each time. All right, so let's say you're investing $1,500. So guys, that's your principal. That's your present value. That's your start money. At an annual interest rate of 7.5%. So clearly that's your rate, but we want it as a decimal, so 0.075. And again, it's not a simple interest rate, it's an annual interest rate. You're going to do it for 3 years, so that's your time period. It will yield what amount of money if interest is compounded in the first example annually? So our compounding period would be once a year, so n equals 1. So all we have to do is plug all of these numbers into our formula and see what the end amount of money is after my interest has been compounded annually, once per year. So A will equal my principal, which is $1,500, times 1, because I'm going to get that $1,500 back. So that's just saying that we have $1,500, plus they're going to take your rate, 0.075, they're going to divide it by the compounding periods. Well, guys, you're only doing it once a year. You're going to get that full 7.5% once each year. So you really don't have to divide this one by one, but I'm just using the formula, so I'm going to put it in. And then it's going to be to the power of, they're going to do this 1 time per year times 3 years. So it's really to the power of 3. So guys, type that into your calculator. 1,500, parenthesis, it'll do the entire thing for you. So 1,500, parenthesis 1 plus 0.075. You can put divided by 1, but you really don't need to the power of 3. Hit enter. And now, after 3 years, your $1,500 has become $1,863.45. Done. That's the whole thing for you. All right, let's do the next example. Same information, but now they're willing to compound your interest semi-annually. So guys, obviously, the more times they're willing to stop and add a little bit of interest in, the better it is for your money, because now you'll have more interest earning interest. So now if they do it semi-annually, that means they're going to do it twice a year. So n is 2. So now what will the end amount be? A will equal, I start with $1,500 times 1, because I'm going to have that $1,500 there, plus, now they're going to take my rate, 0.075. I have to divide it by 2, because I'm not going to get the full 7.5% each time. I get a fraction of it over the course of a year. And then it's going to be to the power of, I'm going to do this twice a year for 3 years. So 2 times 3 is 6. Type that in, does the whole thing for you. And you should see, the more compounding your money gets, a little bit more you get each time, because it's better for your money the more they're willing to compound it. And now we have what? 1870.77. So again, you earned a little bit more money when they were willing to compound your interest semi-annually compared to annually. All right, let's do the next three. I'll do them up here, you guys do them there, and let's see if we get the same answers. So quarterly, N is 4. That means 4 times a year, they're willing to stop, add some interest in, and now your interest can earn interest for those 4 times the year. And each time you make a little bit more money compared to the last one. As they're going to compound more, you're going to make a little bit more money.
We've never recommended the amount of times that it should be.
I'm sorry, you said it should be? I would say the most popular compounding period is monthly.
Okay.
And again, if you don't know what 365 times 3 is, you can leave that as your exponent. I just get a little OCD, and I end up putting it in its own set of parentheses so that it all stays as the exponent. Because sometimes the only thing some students struggle with in these problems is they don't type things in correctly. Are you guys' answers matching mine? Is everybody okay? Yes? Good? So again, hopefully really nice and easy. It's just a formula. We plug some numbers in. The calculator does all the work. It's glorious. It's got to feel nice coming off of some of the problems that we've been doing. All right? Anybody questions? Thumbs up at home. We're okay? All right. So then what happens when we want to continuously compound the interest? What number could we possibly use for n? Well, like I said, there's no number you could possibly plug in that's big enough to show constantly or consistently compounding that interest. So you get a new formula. Okay, so guys, if they're gonna say continuously compounding, don't use this formula because what would you possibly plug in for n? You can't plug in infinity. So you get a new formula that is, we call it PERT. It's your principal times e, because like I said, 1 plus 1 over n to the power of n is very similar to what's already living inside of this function. Guys, this is what they were working on. They were doing a compound interest formula or problem when they discovered the number e. So we know as n got bigger and bigger and bigger, it became e. As n went to infinity, the limit of this number was e. So now we take that part out and we have PERT. So it's your principal times e to the power of your rate times time. So that's your new formula. And again, you'll probably get annoyed when we get into like the next section when we're dealing with maybe some more complicated exponential growth problems. Sometimes you'll see math books, they'll use the PERT formula even if it didn't say the word continuous. Only because it's a much simpler formula to use than that one. So sometimes we'll just, we're only estimating anyway. Let's use this formula because it's a lot simpler to use. But right now, we're looking for the keyword continuous. We want to use that formula. All right, so it says the amount A that results from a principal of $1,000 at an annual interest rate of 10% compounded continuously, keyword, for 1 year. How much money do you end up with? So we're going to use per. So it's P, your principal, which in this case is $1,000, times E to the power of your rate, which is 10%, so 0.10 or 0.1, times the time, which is 1 year. So you just type that into your calculator and hit enter, and it'll tell you exactly how much money you end up having. What's up? You can put 0.10 or 0.1. It's up to you. And you end up with your $1,000 after 1 year being compounded continuously with interest at a rate of 10%. You end up with a $1,105.17. So obviously that would be your best case scenario as an investment standpoint if they were willing to continuously compound your interest. Everybody okay with that? Does everybody feel like this is pretty easy? I like this. This is nice. Yes? Okay. Let's go to the last one. Oh wait, is it 57?
Yes.
Yeah. You know what I'm gonna do, guys? I'm gonna save this, obviously I have to, for tomorrow. We'll start with this tomorrow before we start day 2. I didn't put it on the day 1 homework, just in case we didn't get to it. So all of your homework problems, guys, this might be the quickest homework of the year. Nice and easy, all right? If you have no questions, guys, I have to just double check your